that mean we have to be careful what we say?
Uh, it means I really have to be careful when I'm editing. Now we're recording. All right, good evening. I've got a problem, and I can't mute this computer behind me. Can you hear an echo? No, you don't hear an echo? All right, very good then. My name is Howard Hazelrig. My call sign is Whiskey 4 Papa Hotel. Sometimes I say it's Whiskey for Papa Howard, and I'm Howard. I'm your instructor tonight, and we'll be going into Module 2. So let me see if I can make this thing work. Move over here. I got to sign up. I have two computers here that I'm using for this, which is where most of my problems are coming from. Evidently, I got more problems than I know. At any rate, the exam prep course, Module 2. And we'll start with metric prefixes. It's scientific notation. Metric system is used because numbers cover large ranges of values. Most common prefixes in radio are pico, nano, milli, centi, kilo, mega, and giga. You'll notice that mega and giga use capital G's and a capital M, and I think tera will also have a capital T. Pico is mostly used in capacitors, and one of the things that you hear it called is a micro. So, which a micro is 10 to the minus 6. And we'll move right along. And here's where you see the numbers, and that tera, capital T, comes in. Tera T to the 12th. And you hear that most common, I guess, in computer memory nowadays. Really big hard drive used to be well, I can remember when it was in kilobytes, but now it's in the terabytes. So tera is 1 times 10 to the minus 12. It could also be called 1,000 megabytes, which is 1 times 10 to the minus 9. It could be called 1,000,000 megabytes, which is 1 times 10 to the minus 6, and also is 1,000,000. Kilo is 1,000. So a million is 1,000 kilobytes. A hecto, seldom hear that, but that's 100, 10 to the second. And obviously 1,000 is 10 hectobytes. And a decabyte is 10 to the first or 10. And then there's deci, which is 1/10 of 0.1. Centi, which is 0.01, which is 100th. Milli, which is 0.001 or 1,000th. Micro, which is 10 to the minus 6 or 1,000,000. And nano, which is 10 to the minus 9th. And pico, which is 10 to the minus 12. And we have practice questions here. We have interspersed them. And this is how it works. How many milliamperes are 1.5 amperes? Well, a milli being 1,000 is If it was written, it'd be 1500 milliamperes. And so how many milliamperes are in 1.5 amperes is 1500 milliamperes. Okay, which is equal to 1,500 hertz. Well, they're throwing terms in here we haven't defined yet, but we'll get to them in a few minutes. 1,500,000 hertz. I'll get that right in a minute. So if we look over here, it would be 1,500 kilohertz. When we put the little k in there, we divide it by 1,000, which simply removes that last 3 zeros. Okay, which is equal to 1 kilovolt. Kilo is 1,000, so it would be C, 1,000 volts. I'm having difficulty there. All right. Which is equal to 500 milliwatts. 500 milliwatts is equal to a half a watt, which is 0.5 watts. Milli being 1,000. Which is equal to 3.525 megahertz. So 3.525 would be 3,525 kilohertz. That moves the decimal place by 3 places. Okay. Which is equal to 1,000 picofarads. 1,000 picofarads is 1 times 10 to the minus 12. I believe that's equal to 1 microfarad. Which is equal to 28,400 kilohertz. That would be 28.4 megahertz. That was simply moving the decimal 3 places to the left. Which is equal to 2,425 megahertz. That would be 2.425 C megahertz. Again, we moved the decimal 3 points to the left, and we went from the megahertz to the gigahertz. Frequency. I need to move my people here somewhere. I'm sorry, I have a mouse here that's working with me. All right, radio waves continually vary in strength or amplitude. This continual change is called oscillating. Each complete up and down sequence is called a cycle. Frequency is the number of cycles per second measured in hertz. which was named after a German scientist, Heinrich Hertz. The period of the cycle, T, is its duration. Let me back up one here and see if I... Okay, wave vocabulary. What we have on the right there is the display of a signal with reference to time. And so this display begins on the left and looks like it's a little over 2 cycles, a little more than 2.5, 2.25 cycles. And the vertical, if we were measuring this in a voltage, it would be voltage or power, but in the amplitude is the strength. The frequency in hertz is the cycles per second again. This is how many of these oscillations occur in 1 second. The period, T, is in seconds. They normally reference this from a 0 point, considering that everything above that line is positive and everything below that line is negative. If we look here on the bottom, we see 3 different frequencies. When you generate a frequency, it also generates something called a harmonic. And these harmonics can be a second order or a third order or fourth or fifth and so forth. So what we're looking at there is the second harmonic is twice the frequency of your original cycle. And the third harmonic is 3 times the frequency. There is no such thing as a first harmonic. It is the fundamental. And boy, that thing jumped too, didn't it? Figure 2.2. This thing is blowing my mind. Oh. All of a sudden we jumped somewhere and I don't know why. And we talked about the harmonics. Okay. Phase is used. Let me see if I can get that thing to hide. Phase is used as a measurement of time within the signal. Each cycle of a sine wave is divided into 360 degrees. Phase A, Part B and C show two special cases. I do not understand why I have a black thing in the middle of this screen. There it went. You see the amplitude, and you see in B, that is the difference in timing of 90 degrees of the two cycles. C is 180 degrees out of phase. Come on now. Position within a cycle is called phase. Phase is used to compare how sine wave signals are aligned in time, measured in degrees. Practice question. What is the unit of frequency? Hertz. And you'll learn all the others there later. And this one always makes me laugh because of the pulse rate. But what describes the number of cycles per second that an alternating current makes a complete cycle, which is frequency? What is the abbreviation for a megahertz? This is going to be C, capital MHZ. The HZ is always the abbreviation for hertz. What is the abbreviation for kilohertz? That would be KHZ, with the lowercase k being D. The radio spectrum. This is the way in which they divide the radio spectrum, and they use a multiple of 10. And they say that the audio frequencies go up to 20 kilohertz, and above there you start getting into radio. But they call the frequency from 3 kilohertz to 30 kilohertz very low frequency. Then 30 kilohertz to 300 kilohertz is low frequency. And then 300 kilohertz to 3 megahertz is medium frequency. And your AM radio stations fall in that range. And they call 3 megahertz to 30 megahertz high frequency. They call 30 to 300 megahertz very high frequency. 300 megahertz to 3 gigahertz is ultra high frequency. 3 gigahertz to 30 gigahertz is super high frequency. and 30 to 300 is extremely high frequency. Electromagnetic waves. Electromagnetic waves are made up of electric and magnetic energy. When you put a signal into an antenna, current moving in the antenna creates a magnetic field. As the magnetic field collapses at the frequency at which you're transmitting, it generates an electric field. This electric field radiates from the antenna. And as the electric field collapses, it generates a magnetic field. When the magnetic field collapses, it generates an electrical field. And this goes on forever. When you transmit a radio signal, it will go on forever because one of the laws of thermodynamics, I believe it is, says energy can be neither created nor destroyed. And we'll get into this a little deeper later. The electric and magnetic waves vary in the pattern of a sine wave. Electromagnetic waves travel at the speed of light. Moving electrons in an antenna take the place of the moving magnet. A signal from a transmitter can make the electrons in the antenna move, transferring energy from the signal to the electromagnetic wave. The same process works backwards also. Electromagnetic waves encountering an antenna make its electrons move in sync with the wave. Electromagnetic energy is transferred from the wave to the electrons in the antenna. Moving electrons create a signal that can be detected by the receiver. Electromagnetic waves travel at the speed of light. Moving electrons in an antenna take the place of the moving magnet. A signal from the transmitter can make the electrons in the antenna move, transferring energy from, and I went through that a while ago, and it can work backwards too. Electromagnetic waves. Moving electrons create a signal that can be detected by a receiver. The electromagnetic spectrum is divided into range of frequencies in which electromagnetic waves behave similarly. Each range or segment has a different name. Waves of a certain range of frequencies, which can be used for communication, are called radio waves. The range of signal frequencies is called the radio spectrum. It starts at 20 kilohertz and continues through several hundred gigahertz. A specific range of frequencies in which signals are used for a common purpose or have similar characteristics are called a band. Frequency bands used by hams are called amateur bands or ham bands. Frequencies above 1 gigahertz are considered to be microwaves. And this is what I went through before. Very low frequency is 3 kilohertz to 30 kilohertz. Low frequency, 30 kilohertz to 300 kilohertz. Medium frequency, 300 kilohertz to 3 megahertz. High frequency is 3 megahertz to 30 megahertz. This is where most of the fun in amateur radio happens, in my opinion. Very high frequency are 30 megahertz to 300 megahertz. Ultra high frequency, 300 megahertz to 3 gigahertz. Super high frequency, 3 gigahertz to 30 gigahertz. And extremely high frequency, 30 gigahertz to 300 gigahertz. As a radio receiver is tuned across the AM broadcast band, starting at the left, it encounters each signal in turn. Between the signals, only noise is received. Although signals can be received slightly lower and higher in frequency, the signal is best received when the receiver is tuned exactly to the signal's frequency. Practice question. What frequency range is referenced as very high frequency or VHF? That would be 30 to 300 megahertz. It would be B. Oh, it says, yeah, that's correct. What frequency range is referred to as UHF? That would be 300 to 3,000 kilohertz, and we have several ham bands in those ranges. And that would be C. What frequency range is referred to as HF? That again is C, 3 to 30 megahertz. What is the abbreviation RF mean? A, radio frequency signals of all types. Wavelength is the distance a radio wave travels during one cycle of the wave's electric and magnetic fields. Lambda is the symbol for wavelength. Waves travel at the speed of light, which is 300 million meters per second, or 3 times 10 to the 8. And in my opinion, this is the most useful expression. If you use 978 million feet per second, it's a little harder to fool with. Hams can refer to bands by frequency, such as 50 megahertz, or wavelength, which is 6 meters. Because radio waves travel at a constant speed, one wavelength the distance of one wavelength is the reciprocal of the frequency of the speed of light. I mean, the speed of light divided by the frequency in megahertz. As a radio wave travels, it oscillates at the frequency of the signal. Wavelength is the distance traveled by the wavelength during the time for one complete cycle. In the beginning of radio, it was actually easier to measure wavelength than frequency. And they had a simpler method of measuring wavelength than frequency. They could stretch 2 wires out from an antenna and measure the voltage as the wave varied and find a wavelength almost exactly. A radio wave can be referred to by wavelength or frequency because the wave is moving at a constant velocity. The speed of light, if you know the frequency of the radio wave, you automatically know its wavelength. Practice questions. What is the velocity of a radio wave traveling through free space? A, the speed of light. What is the relationship between wavelength and the frequency? The wavelength gets shorter as the frequency increases. So that would be B. What is the formula for converting frequency to approximate wavelength in meters? Wavelength in meters equal 300 divided by the frequency in megahertz. In addition to frequency, which of the following is used to identify identify amateur radio bands. The approximate wavelength in meters. Traditional letter number next. Channel numbers. A, the approximate wavelength in meters. What is the approximate velocity of a radio wave in free space? 300 million meters per second, B. Radio equipment basics. The basic radio station, called a transceiver, and it's made up of a transmitter, a transmit-receive switch, a receiver, a power supply, and an antenna. The transmitter, which is abbreviated XMTR, generates a signal carrying Morse code, speech, or data, or video. Receiver, abbreviated RCVR, recovers the signal from someone else's transmitter. Antenna turns signals from a transmitter into radio waves, captures signals, radio waves, and turns them into signals for the receiver. A feed line or transmission line connects the antenna to the transmitter or receiver. Most systems combine transmitter and receiver into a transceiver, abbreviated XCVR. Practice questions. A device, well, what is a transceiver? A device that combines a receiver and a transmitter. A. Only one question in that group. Okay. Radio equipment basics continued. A repeater is a transmitter and receiver connected through a duplexer to an antenna. The duplexer replaces the TR switch and allows a repeater to receive and transmit at the same time. There's a delay that this mouse is causing me a lot of troubles with. Repeaters consist of a transmitter that retransmits info from a received channel simultaneously on another frequency or channel, called duplex communication. Usually located on high buildings, towers, hills, mountains, etc. for maximum range. We're fortunate to have the mountains here. Provide local and regional communication between low power stations. Often used for local emergency traffic. Can be used for voice, data, video signals, and voice is the most common. The duplexer allows the repeater's transmitter and receiver to share an antenna at the same time. Practice questions again. What type of amateur station retransmits the signal of another amateur station on a different channel or channels? A repeater station. And that's the end of module 2. All right, let's start with questions. Comments?
I do. I have something.
All right. First, let me get you up here where I can see who you are.
It's Mona.
All right, Mona, go ahead.
I didn't grow up speaking this language, so this is pretty overwhelming and confusing, and it might help if I had some context to it. You know, what is it that the people that grant the licenses are looking for from us? Do they expect us to be able to converse this way?
This license is basically to keep you out of trouble. You're going to learn a little bit about communication. You learn about the frequencies you can use and what you can and cannot do on the radio. For instance, amateur radio stations cannot play music. And they expect you to understand a little bit of this enough to get to the point where you get your license.
Okay, I can understand that, but being able to spout off megahertz and kilohertz and all of that, is this going to be like 40% of the test? Is it going to be 5% of the test?
Probably closer to 5% than 40.
Okay, that's helpful.
There are, what, about 450 questions in the question pool?
Uh-huh.
Yeah. And you have seen the questions that cover this material.
Okay.
And you will only have 30 questions on your test.
35.
35,
Yeah.
I'm sorry. So the odds are you might not even get a question about this at all.
Don't tease me.
Well, back up from that. I can promise you that you will get one question. Now, which one it is, you know, I said earlier that sometimes you see the same question asked from 2 different directions.
Right.
That's what you saw in that list of questions. All of those questions are in the pool of questions. You will probably get one of them, maybe. Again, when you pull 35 questions out of a pool of 450, you're not going to ask the same thing more than once. And if you're real lucky, you may not even get asked that question. I'll relate this. When I took my extra exam, every question that we pull, every test we hand out has a different set of answers. Like if you looked at your neighbor's answer sheet and copied it, you're going to be wrong because their test is different.
Well, you'd be a dirty, lousy cheater.
Well, we wouldn't know that. We would just say you got all the questions wrong.
Basically,
But my point is, if I had been sitting one chair to the right or the left of the chair I was sitting in, I would have been asked a different set of questions than what I was looking at. And I was real fortunate that day in that I got a test that had questions that I knew the answers to. If I had moved one seat to the right or left, it might have been a little different situation. Don't let that intimidate you, because again, you were asked the same question coming from 2 or 3 different directions. You're not going to be asked to do all of those questions. You're going to be asked to do maybe one of them. So,
And Mona, what too, well, for all of you, I'm the VE team leader, okay, and Bob is, and in our test kit, we have 10 different tests of the technician. And like I say, each one is different. And when I pull one out, I don't know which one I'm giving you. And when you go to take the practice test on some websites that I'll go into later on when I teach, you need to take all the practice tests, each variation, okay? And a lot of this, I refer it to as high school. Remember in high school, you had to take courses that you'll never use again. And some of this, that test questions, you know, you have to know it to pass the test, get your license. But some of it you'll never use.
I guess
So-
that's what prompted my question. I
Yeah.
was wondering how stressed do I need to be over this particular module?
Can I jump in here?
Go ahead, Rick.
Yeah, the answer to your question is you need to know enough about megahertz, gigahertz, et cetera, that if you're talking with another ham and you say, well, what frequency did you hear him on? And they tell you, well, he was on 146, 540, that needs to mean something to you. You know, if he, well, actually they're going to say he was on 146.54 megahertz because you're new, he's going to expand it. For those of us who deal in VHF regularly, 146.540 or 146.54 megahertz is a common calling frequency on 2 meters. And so, which is a VHF frequency that we use. But if he said that, you know, he's on 146.54 megahertz, that needs to mean something to you. You need to know that's a VHF frequency. You need to be able to, you should know it's in the 2 meter band, and that as a tech, you would have the privileges to use it.
As opposed to somebody telling me they're in some range that I'm not supposed to be on? Is that what you're saying?
Well, if he tells you he's down on a 14.28 megahertz, which is the, let's see, 14, it'd be the 20 meter band. If he's down on 20 meters, then yeah, you don't have privileges there as a tech.
Okay, well, that makes sense.
So,
You
you know,
you
that,
can listen to him, but you can't talk to him.
Yeah.
yeah,
Okay.
right.
Well,
Right.
They should be a band plan in your book somewhere.
Yeah, there he
You'll
is.
need a copy of that. And also, this is something I'll go over. And also the codes, Q codes. Everybody will need to print out a copy of that. Keep it close to your radio. Once you've been in this for a while, all this will come naturally. And you're going to hear us repeatedly, and I mean repeatedly, especially me, encourage you to get on the radio. That's the way you'll learn, is getting your license and getting on the radio. You'll learn more once you start getting on the radio and then understanding it a little bit better than out of the textbook.
Well, I don't want to monopolize the class. And Randy, you've already promised that we can call you if we have questions. So
Yeah, that's fine. Yeah, that's
Yeah.
fine.
And me
Yeah.
too.
Okay.
And
But
don't be
yeah,
afraid to
remember-
ask a question.
Oh, I don't.
I mean, it's the dumbest question is the one that you never ask.
Yeah.
And if Randy, if you hear Randy and I talking about him, and I say, well, I'm gonna go up to 440. He says, okay, I see you up there on, I think it's 1.25. I'm saying frequency and he's saying wavelength is the same place. What you need to understand is we're saying the same thing. Don't worry about the units, but just have a little general feel for it. And again, keep in mind the goal here, and I don't like saying this, especially to new people, but your number one goal here is to pass this test.
Yeah. And it'll be confusing and you'll get frustrated at first, but don't let that intimidate you.
No.
It'll come to you. It'll come to you. We'll keep going over this stuff.
And then just one more question. When you say that you're going to encourage us to use the radios, you're talking about after we're licensed.
Yes.
Yeah. After you get your license. You can buy a radio and listen all you want to. The license gives you permission to transmit.
Will you during this course tell us how we can get on the radios if we have them in order to listen?
Yes, we will do that. That is part of my chapter 6.
Okay.
I'll go over that very, very thoroughly. I'll go over more repeater information, such as input, output, PL tones, offsets, stuff you don't understand now, but later on you will understand it. And I'll go very, very slow with this, where you can comprehend it and hopefully understand it and get a better grasp of it, I should say.
Well, thank you for indulging me for some clarity.
No, that's fine. That's fine. We don't mind that.
I have a dumb question.
Well, before you go on, let me point out, if you're looking at Randy, say something, Randy.
Okay.
Okay.
What do you want me to say?
Well, nothing now. That I've got my screen set up to show the speaker. In the upper right-hand corner of Randy's screen, you see this little blue box with a bunch of green and red marks in it? Yep. That's the band plan. You got one of those in your book. Now, here's the guy with all the experience, and what's he got back there behind him to remind him?
Not only up there.
The band plan.
I got one right here.
Yeah, I got
That's
one
the band
too.
plan. Okay. And I will go over this a little bit. And it's basically self-explanatory once we get into it a little bit.
My point here is all of us that y'all think know everything, we know which piece of paper to pick up to find it.
And every one of us started where you people are starting.
Yep.
One thing
Every
I'll add,
one of us.
one thing I'll add as well.
Let's get Ann's question.
I was just, because I know you had mentioning about the test, and like I said, I know nothing about anything. And you're saying it's about 35 questions. Was that correct? Did I hear that right?
Yes.
This test. And is it, how many do you have to get right to pass?
26.
46.
26.
Oh, 26. I thought, ooh, my math is all bad.
26 out of 35 is passing.
So, okay.
Now, we don't grade this A, B,
Okay.
C, D, F. You either pass or you fail.
Correct.
Okay, don't worry about, oh, I missed 4. Oh my God. Don't worry about that.
Gotcha.
It's you pass. That's what you want.
Yeah.
Now, I will say one thing. It depends on, I know some of y'all are not in our area, and it depends on who y'all test with. It's anywhere, well, some do it for free, but they're few and far between. But usually testing, you have to pay roughly anywhere from $10 to $20 to take the test through the club that offers it in y'all's area. Then this past summer, the FCC instigated a fee for new hams of $35. Okay. And we'll go over that a little bit more better in detail, but there is some additional expense. Now the license is good for 10 years. And basically, the FCC fees are for new hams, license renewal, and vanity call signs. In other words, if you want a special call sign that nobody else has, you have to pay the $35 fee for that. Now, once you pass your tech test and later on you want to upgrade to general, there will be no fee for an upgrade. It's just those three things: new hams, license renewal, and vanity call.
Well, each time you take the test, you're going to pay the VE their fee, but you don't have to pay the FCC.
Yeah. So again, fee to take the test, and the fee for the FCC. So that's what we're looking at.
And you only pay the FCC after you pass the test.
Yeah, after you pass it. And they'll send you an email, and again, we'll go over this again, but with when you have to fill out a form when you're taking your test, that goes to the FCC, including email. Then they'll send you an email, and you have to pay this fee within 10 days. So I don't send them a check. Just as soon as you get this email from these people after you pass, pay it with a credit card immediately. Then they'll send you your call sign. Then once you receive your call sign, you can get on the air or see it in the database, in the
I'll
FCC
talk about that
database.
in session 8.
Yeah.
And
So we'll go over all this stuff again.
And all of the stuff that Randy has told you, since I've reviewed that session, I can tell you that most of what he has told you is going to be the answer to one of those questions that you may or may not get on that test. I was surprised at what they did, but it's in there.
But like I said, don't be intimidated at
No.
first. A lot of this
No.
is very confusing, but you keep studying and reading the book and stuff, and it'll come to you. And the test is really not that difficult, as long as you study a little bit. And we've had 6-year-old kids pass this test.
Oh, I'm so way past 6.
We've had a couple of them. We had a gentleman who was part of the original club that this club came out of. This club's a merger of two. You can read that on the history on our website. But he was back in the days before most of us here were born. And he finally got his license when he was in his late 70s. And he had a stroke. He could not write. And then CW, copying code was part of the test for a novice license. He copied it in his head. And then we asked him the questions and he gave us the answers.
Yeah.
So whether you're 6 or 70,
don't matter.
don't
And
matter.
we test blind people, hearing impaired, whatever. And there's special ways we do it. But don't worry about the test right now. Just study and learn. It'll come to you. It'll come to you.
And one thing that I'll say is that the learning begins as soon as you pass the test. I mean, seriously, it's most of what you're going to learn about amateur radio is not going to be from this class, and it's not going to be from getting your license. It's going to be after you have your license and get on the air with it and participate in activities and just be active in the ham radio community. That's where your learning is going to come from, and that'll never end either. I mean, you could do ham radio for 70 years and still not learn everything about it.
Yeah,
that's kind of that's one thing to look forward to.
I can say I've been doing it for 60 and I'm still learning.
No, I'm just halfway there because I've only been doing it about 35.
It's a continuous learning process. It really is.
It's fun.
Yeah, it's fun. And there's different modalities you can do if you like computers. And Harry does this, and Howard and Zach. I don't. Something like FTA, which you hook up your radio to a computer.
Mm-hmm.
There's slow scan TV, again, digital, hook it up to a computer and print out images. WinLink, you can send emails through your radio. I mean, there's all kind of modes out there. It depends on what you like and what you do. The digital stuff I do not do. I don't like doing it. What I like is voice communications, and that's what I do. When I call somebody, I want to talk to them.
And there's challenges you can set up for yourself. One of the things I wanted was called 5-band, worked all states. That means you could make a contact with every state on 5 different bands. And these bands are the 80-meter band, which is 3.5 to 4 megahertz. The 40-meter bands, which are 7 to 7.3 megahertz. The 20-meter band, which is 14 to 14.3 megahertz. The 15-meter band, which is 21 to 21.45 megahertz. Or the 10-meter band, which is 28 to 30 megahertz. So it took me from 2013 to last year to make that 250 contacts.
And
I'm still working on
short too
mine.
on 10 meters.
Yeah.
Right now I'm working on DXCC, which is 100 different countries on 5 bands. And I like a few on 80 meters and I like a few on 10.
Yeah. And again, I'll go through this when I teach, but there's contests out there that you can do, such as 13 colonies, which happens the week of 4th of July. And what you do is get on there with people that's in these states as like a net control. We'll go through that again too. But you make contact with all 13 colonies, and you get, if you want to, send it in, and you get a certificate. And this is basically what the 13 colonies you get. It's just something that I like to do. There's special events, which is bicycle races, marathon runs, et cetera, that we participate in, provide communications. Those things I love doing. I'd rather do that than anything, because I get out, get to go. My wife and I, she communicates. She got her ham license, and we go to parts of Western North Carolina we never normally wouldn't go to, and see the sites just to help out with the races. That's one thing I like doing.
There's one that Zach and I do called Summits on the Air. You go to the top of a mountain, set up your radio, and talk to as many people as you can.
In case y'all were wondering, you'll hear us every now and then talk about my radio has cat control. You just saw my cat.
And her call sign is K4CAT, right, Harry?
Well, Mike Echo Zero Whiskey.
K0AT.
Does anybody else have any questions? Is everything clear as mud?
Yeah, it's like mud sometimes.
Yeah. But like I say, Mike, it'll get better. It'll get better. Just
As
do
new
the studying
tech,
now.
Yeah, as new technician licensed hams, you're going to find that you're going to spend most of your time, probably, there are exceptions, but most of your time on VHF, UHF, you're going to be using repeaters, and we do cover that pretty good in the class. You're going to come out of here with the ability to set up a radio, to work with a repeater, and make contacts. So, and then the HF stuff, there are limited privileges on HF for technicians.
Yep.
But most of it will be VHF and UHF using repeaters, or just person to person, radio to radio.
However,
And rule of
if you look
thumb.
at- if you
Yeah,
look at
go
the
ahead,
band
Harry.
plan, you do have voice privileges on 10 meters. So don't give up on that.
And rule of thumb, technician license is basically local communications. By local, depending on the repeater and different things, roughly 200 mile, maybe 300 mile range.
Another question for Harry. Harry, what did you mean by you have voice privileges on 10 meters?
What's that mean?
Well, number one, I'll talk about that in lesson 8 when we talk about regulations, because that's the terminology we use when we talk about what modes you can use. You will have CW privileges in certain parts of all the bands.
Now, CW is Morse code.
That's Morse code again. To go back to Mona's question originally, that's part of the jargon you hear us use. Howard covered continuous, and I'll talk about continuous waves in lesson 5. Then you have data privileges, and you do have them on 10 meters, and that's using your computer and your radio. And then you have voice privileges, which are primarily single sideband. Now, as a technician, there's some other privileges that you have to be a general to have, but so we're only going to talk about what you can do as a technician. But that means you can talk on your radio on the 10 meter, or is 28.3 to 28.5 megahertz. You have voice privileges there. You can talk to somebody.
All over the world.
That's what I mean by privileges.
And you are getting your license at an opportune time, because during the height of the sunspot cycle, you can talk to the world on 10 meters.
Yep.
Oh, okay.
And during the low point, you can't get across the street.
Pretty much. However, I'll throw this in.
Hear
On
that?
10 meters with your computer, it was still alive in the low sunspot
That's
cycle.
Mexican hams.
There is something out there, regardless of what you want to do. I didn't get into digital until the sunspots went away, and I tune up and down the bands, and I might hear a voice talking somewhere. I don't do CW. I do not hear the difference between a dot and a dash above about 7 or 8 words per minute. After that, it's just, that's all I hear. So I don't do CW. Some of these other guys do, and they're quite good at it. And if I listen to them, that's all I hear. I can't tell you the difference between a dot and a dash. But I got turned on to digital, found out how to connect my old radio to the computer, and never looked back. And that was when the sunspot cycle was low. Now I'm beginning to have to start learning how to talk again, because the voice part is coming back with the increased sunspots. That part of the band is opening back up again. So like I say, there's something fun. I don't care what you want to do.
And also, the universal language for ham radio operators is English. And mostly you hear that on with a general license and HF. But if you can speak a foreign language, and I go over this when I teach, and say you get an Italian ham, and you can speak in Italian, so you can actually converse with that ham. After you make the contact in English, you can speak to them and converse with them in Italian. So, there's different things you can do with that too. So, but again, we'll go over all this.
Okay.
There is something in ham for everyone, whatever your interest is. And my interest has changed. I had no interest in digital. Harry got me interested in digital. I have a friend who, how many contacts did Daryl say or how many countries did Daryl say he got for new countries this weekend? Was it 10? 12?
10 or 12, something like that. And he's a parts on the air guy. That's what turns him on. But he found a park, where was it, in Trinidad? One of those little islands in the Caribbean. And here's part of the fun now. Hadn't got anything to do with your radio. But you go out, you Google Trinidad. And then you go from there. And he found out that this park wasn't a whole lot bigger than the guy that was standing in it, making the contact. But that's part of the fun of this, is chasing down some of that information. I was trying to figure out where there's a group on St. Brandon Island. Took me a while to figure out that that's just above Madagascar. But again, that's just all part of it. Chasing down that information, because they didn't give out one piece of information I needed, and I had to chase it down. They didn't put their grid square in their call sign, and when you're doing FT8, that's part of the information you keep. And we'll tell you, and I've thrown another piece of jargon at you, you don't know what a grid square is yet either.
No, I imagine it's like that.
Yeah. Well, the Earth is divided up into 1 degree by 2 degree pieces, and they all have a name and a number. And I won't tell you more than that.
Because my head's gonna know how to turn the radio on.
There's what a piece of, I don't know if
You back it up till it focuses.
huh?
Back up.
Tell me when I'm in focus, because I got that between me and the camera.
Nope.
Keep going.
Keep going. Yes.
And talk.
It ain't gonna happen.
Okay. Anyway, that's just the United States. Now, again, keep in mind, if I want to know where something's at, I unfold this piece of paper and look at it. I don't remember any of that. And there's not going to be a question on this exam about that anyway, but
you do remember our grid
remember where you put the piece of paper.
And we use grid squares because we can send that information faster in less characters than you could with longitude and latitude.
Yep.
Is there a way that we can access that information that you have, those maps and
Oh, yeah.
the criteria that you're using?
Yes.
Yeah. And like my location at my house is EM 85 PM. And that gets them right down to a very precise location if somebody wants to know exactly where I live.
And actually,
And that's 6 characters. EM 85 PM. That's only 6 characters, so it's real easy to send that with Morse code. It's much faster than trying to bang out your longitude and your latitude in degrees and minutes and seconds, or degrees, minutes and portions, decimal parts of a degree of a minute.
Yeah.
That's much more difficult to do. Takes more time, and you got to remember more numbers. So, but grid squares are not part of this test. And the only reason I learned about them was because I started doing the digital stuff. And like Harry said, the FT8 wants to know your grid square. So I had to find what my grid square was so I could put it into the program so that it would broadcast my grid square when I made a contact.
Google is your friend.
Yes.
And
So is YouTube.
the name of it is Maidenhead Grid System.
Yep. And right here above me is the grid map. And I'll show that when I teach.
Yeah, that's what I was trying to show them, is that mine's not colored, but that's how you know.
Okay, good.
I actually use a piece of software on my computer that shows the whole world. I can zoom in anywhere on the map, and it is in grid square. So, the name of that software is called Grid Tracker.
Yeah.
And you can download it for free, and if you turn on the grids, it doesn't normally have the grid on, but you can turn on the grids and it shows you all of them around the world and blah, blah, blah. But I never even heard of Maidenhead grid system until I started dealing with FT8. So, and that was just, it was right after we did field days last summer. So, you know, late June, early July, first time I'd ever heard of it. So, but like I said, there's something for everyone in this world of ham. You know, Daryl, and you know, he stays home during the daytime, and he probably makes between 40 and 60 contacts a day with people.
Yeah, he's disabled, and he's had several strokes, and he is on disability, and he's been a ham roughly about a little over a year.
Yeah, I was going to say about a year and a half. Yeah.
Yeah, he's jumped into it with both feet, and you know, Harry, myself, and Rick went over and set up an antenna for him, and you know, he got him some radios, and has been loving it, going to it all the time, and it gives him something to do. And but also with when I teach, I actually show you how to use your radio. I will show you all that.
That'll be useful.
I will show you how to use a radio.
So when you use your computer to do any of this ham stuff, do you need the internet for that?
No.
It helps. You don't have to have it.
Thank you, Rick.
No
What-
problem.
One thing I'll add too, you know, Randy mentioned going and setting up an antenna for Daryl. That's one thing, you know, about the ham community is there's a very good, very supportive community in ham radio in most areas. And, you know, we mentioned all this jargon we keep throwing around, and it sounds like we're speaking some foreign language. You know, one of the things is once you get started in this, if you don't know what something is or what it means, just ask. You know, a lot of people will really be happy to explain it to you and help you understand it more. And before you know it, you'll be answering other people's questions.
Yeah, of course, every answer starts out with, "You mean you don't know that already?" No, actually, we're good about it. You know, I kind of work as Daryl's Elmer, and I've helped him out on some things. He got into this Parks on the Air deal, and initially he was what they call a hunter. He stays home and responds to people who are in a park and calling, you know, looking for contacts. And so he would respond to them. And then he decided he wanted to start activating a park, which means you're in the park looking for contacts. And so I had to, we came up with a 40 meter and a 20 meter dipole that we could quickly and easily set up on a park site, you know, so I'll rope up over a tree, and within 5 or 10 minutes of arriving at the park, he's on the radio transmitting. You know, so yeah, I helped him out with that. It's, and I usually go with him when he goes, because with him being in a wheelchair, it's kind of hard for him to get a line up in a tree, but we have fun. So, you know, it's a good time.
Yeah, and more jargon, dipole, what Rick's talking about, dipole antenna, and you'll hear this quite frequently. A dipole antenna is a wire antenna. That's it, just a piece of wire. It's cut at a certain length to use
Why did
as
they
an
call it
antenna.
wire antenna?
Well, some do, but
That'd be too easy.
Yeah, I sometimes call it a wire antenna, but more, you know, just it's one of those things you need to learn. Somebody says a dipole, oh, he's using a wire.
Well,
it's
it's a
a-
little more specific. The
Yeah, it's
dipole,
a type of a wire antenna.
Yeah,
Yeah.
right.
Yeah.
A dipole is basically your connection to your radio is in the middle of the wire. And then there's also what they call in-fed antennas, where your connection to the radio is connected at the end of the wire. So there are different style of antennas, and yeah, it is a language you'll learn, and believe me, you're going to hear these terms a whole lot during the classes.
Yeah, you're gonna hear us talk about it because we're used to saying it, but just remember, it is not going to be on your test.
You know,
Oh, that will come later, but not on this one.
Okay.
Right.
Again,
But you're still going to know about them before the class is over. Even if you're not tested on it, you're going to have the knowledge just because you need a certain amount of that knowledge to talk to other hams.
well, first of all, you had to know what an antenna was. What does it do? Which is what Howard showed in that one little square. And you will see that picture again in number 5. I talk about it a little bit more, but you have been introduced to the word. So when I go over that in the 5th session, it will not be a new word to you. It will not be a strange noise that you have never heard. And that's sort of the way this works. As you hear a word, you may not know what it means, but then when you've built up enough knowledge for it to begin to have some meaning, it's not going to be a new noise to you. It's going to be a word. Oh, antenna. Yeah, Howard talked about that a couple of 3 weeks ago. Now I know what it is. Okay. And at this level, that's really all you need to know.
That's true. My head's already exploding.
Crashing.
Yeah.
Crashing.
And next week when I get into the electrical stuff, you're going to hear, milliamps, millivolts. You're going to hear, megacycles. You're going to hear, kilovolts. So you're going to get more time with those words.
Yeah.
The next 2 classes, I'm going to do it. And then after that, others are going to be doing it too. So by the time you're done with this, you won't even think twice what's a mega or what's a milli, or it's just going to be there.
Yeah. Okay. Well, all right. Maybe there's a little light at the end of the tunnel.
There
Well,
will be.
No, you haven't got in the tunnel, did you? Don't be looking for the
Oncoming train. An oncoming train.
Well, one thing that I'll say,
you need to duck. It's a train coming.
well, one thing too, this class, I mean, a lot of the stuff we'll discuss later will build upon what you've already learned in the class. So you may get a bunch of information now that's a little bit much to take in, but as time goes on, you'll kind of make connections with what you've learned in the past and what you're learning currently, and it'll kind of really help pull it all together.
That's good. That's good.
Yeah, we're laying a foundation here, and you'll be solid on the foundation before we start building the rest of it.
Okay. Well, that's good because we're going to hold you to it.
Okay, you'll see.
You will.
Okay.
Any other questions?
Not tonight, not for me, but then I've hogged the whole meeting.
Again, on Friday mornings, most of us at the Ingalls on Brevard Road, that's across from the outlet stores, about 10 o'clock in the morning. If you
Working.
want,
Yeah. Sorry, still have to work for a living.
it's a mean old world, isn't it?
yeah, if you can make it. If you want to bring a radio to, program frequencies in there, we can do that.
Okay.
Not a problem.
Well, Zach, maybe we'll see you tomorrow at the meeting.
You muted, Zach.
Yeah, thanks, Randy. Hopefully see you there. We're still on for that. So come on out. We'd love to have you.
All right, great.
Forward to it.
Yep.
Mono and Leslie, we need to make a day trip and go to Ingalls one day.
That's true. Well, I think we're going to stand up because we've been sitting all morning now. I mean, all evening. But thank you so much for tonight.
Okay, well, chapter 3 next week.
Gotcha,
Okay.
guys. Thank you.
Got it. Thanks,
Good
guys.
night. Good night.
Good night.
Thank you.
Uh,
Good night.
Zach, what meeting's tomorrow?
It's the Haywood County Amateur Radio Club, and anybody
Okay.
else is welcome to come too. We meet out at the First Presbyterian Church in Waynesville, 7 p.m. on the second Thursday of the month, which is tomorrow. Normally we meet downstairs in the basement, but it's being renovated due to some water damage that they took down there. So we're meeting upstairs now.
Okay.
But it's right there off of Main Street, just right at the end where Russ and Walnut and stuff is there when it gets into
Okay.
town.
Well, North Carolina DX and Contest Club's also tomorrow evening, so I just wondered.
Yeah, and that going out to there's too, as my grandpa used to say, too fur and snaky for me to drive.
Well,
I see Tommy down there.
Yeah, Tommy joined us. You're welcome, Caitlin.
I'm sorry
See you
I'm
next
late.
week.
Sorry I'm late, but I got in. Part of it.
Well, your audio's better here than it was last night, Tommy.
Last night, well,
Monday
I'm on
night.
a different apparatus.
Monday night. Yeah, I don't know. When you were in, you were loud, clear, but it was broken up a lot. So I don't know if you got a loose connection somewhere or what, but it wasn't. And if Steve were here, I'd ask him if he was hearing you solid on input. That'd be the person you'd want to talk to, Tommy, because if Steve hears you loud and clear, then the problem's not yours.
Okay, well, my antenna analyzer has been borrowed since like last August, and it hadn't come home yet.
Well, I think
Thought
when
I'd
you
try
say
out.
your antenna analyzer, you need to say his antenna analyzer and go borrow it.
We got subject put some more when he put it out, so he's gonna monitor.
So by the way, while everybody's here, I do have a question myself about a little bit more advanced topic, and some of the antenna gurus in the room can help with this. Have y'all ever attempted to test a balun with a resistor?
I fully believe, I think Rick has a method for doing that.
Yeah.
Because one thing I've heard is that you can basically attach resistor across the output of a balun and then measure the impedance at the input of the balun and kind of figure out what ratio it is. But I've now currently tried that with two different baluns, and I've got an analyzer that graphs it for me, and the impedance looks like a big sine wave as it goes across the HF spectrum.
Yeah, I don't have an answer for you. They might be talking about a different Rick, but I don't have an answer.
I
think one thing you can try, Zach, is put a potentiometer across it.
Yeah.
And then at some frequency, adjust it for a dip and then measure that potentiometer.
Yeah.
That's a good idea. I had not thought of that. But yeah. Let me turn the scanner off here. But yeah, because it's weird. I've got basically what's led me to doing this is where did it go? Well, anyways, it's somewhere around here. I've apparently dropped it somewhere. I have a balun that I bought online. It was a little cheap Chinese job, and it claims to be a 9-to-1 balun, but the windings do not suggest that. And there's been a few people in the reviews also say that they think it's about a 5-to-1 or a 6-to-1 instead of a 9-to-1. And I was trying to verify that, but like I said, I'm getting that weird sine wave. But I checked it on what should be a 9-to-1 because I had somebody check it for me at one point. And even it's looking like a sine wave. So I don't know if maybe it's got something to do with, the analyzer only works with loads that are close to 50 ohms or what the story is there.
Well, I think if you do the pot, I think that will work.
Yeah, that's a good idea. I'm gonna have to see if I can find one over here in my junk box and check that out. Because I was getting everything from it being a 4-to-1 balun to it being a 10-to-1 balun, and everything in between.
Probably a 1K pot would cover it, or 5K, because if it's 9, you ought to read 450 ohms.
Yeah. I cannot remember, but going back several QSTs, there was a club made some baluns like that, and they showed how to test them to check and find out. And I can't remember which QST that was in, but I've read an article about how to do that, and it's not hard to do. And you don't need an antenna analyzer. You need like a voltmeter or something like that. Oh, I'll scrounge around in my books and see if I can find that.
Yeah.
One thing I might try is put a known voltage, AC voltage on it, small AC voltage, because you have your impedance ratio is the square of the turns ratio.
Yeah.
So if you get a 3-to-1 voltage difference, then that would be a 9-to-1 Bolin.
Yeah.
That's a good point too. I didn't think of that either. So.
That's
So
that's
you
more
can
what
put
I
in a
was
small,
remembering.
yeah, you can put in a small AC signal and check, what the voltage difference, what it changes to.
Yeah. Thank you. Yeah.
With what I have here, that's probably what I would have to do to get an idea. I don't have better equipment that would give me a direct answer.
Cool. Thanks.
Okay.
Actually, your AC signal on your scope would work real well, Rick.
Yeah. Yeah.
So yeah, that definitely gave me some things to try in the meantime and see if I can figure out what this thing is.
Have you looked inside to count the turns?
Yeah, and it's got, I think it's like 6 turns on it instead of 9. But it looks like a 9-to-1 because you got the 3. You know how you with a 9-to-1 you take 3 wires and you turn it 9 times. It's this one. It's got the 3 wires, but it's only turned 6 times. So maybe it's like a
Say that again now.
Yeah.
How many times you go through the toroid?
So on a 9-to-1, you usually take 3 wires and you wrap those around. You go through the toroid 9 times.
No, you
Or
just go through the toroid until you run out of room, and then it's how you connect the ends of those 3 wires together. Is how you get the ratio. Now I'm thinking of a 9-to-1, what they call an auto transformer, like you would use on an end-fed.
yeah,
And basically it's the 3 wires, and then on the first wire, you take the input, and then you take the second wire and hook it to the end of the first wire, and then you take the beginning of the third wire and hook it to the end of the second wire, and your antenna goes to the end of the third wire.
yeah.
So yeah,
Yeah.
49-to-1 is a little harder to see because then you got to have, what is it, 2 turns and 14 to get the 7 to square. That's where they'll twist the 2 of them together and wrap it twice, and then you got all the rest of it covered, the rest of the toroid to get you the 49-to-1 ratio.
Oh, okay.
Right. It's the ratio of the turns, not the actual number of turns.
Right.
Oh, okay. Thank
So
you.
when
Yeah, because I've never really done much with balance at all. Most antennas I've built that have balance, I've just gotten pre-built balance and done them. And so.
Well, if you found a good source of 240 toroids that were less than $10 a piece, that puts you in business for about anything you want to do.
Yeah. Yeah, and that's the thing too, is the couple of them that I've built have been from, okay, use this specific toroid. Okay, wrap it this specific number of times,
Yeah.
Well, having more turns is a good thing because you just get better, I'm going to say the word coupling.
Yeah.
But it's the ratio of the turns that determine what it does.
Yeah.
That's why I say when you look at a 49-to-1, to get that 7 turn ratio, they will take the 2 wires and they'll twist them together, and they run the twisted pair through twice. That's 2 turns on the primary, and then to wrap the rest of the wire around the toroid to get the other 12 turns, so that you've got the 2 to 14 to get the 7 to square.
Okay. Yeah.
Took me a while. I watched that done, and it took me a while to get my brain to comprehend. Yeah, that's what they're doing.
Yeah. So, yeah, in that case, I may, as soon as I find it here, I think I've set it down in a pile somewhere and it swallowed it up. But as soon as I find it here, I'll kind of look more at the ratio of the turns rather than, the total number.
Yeah.
Because it looked just like a 9-to-1 on the inside. I didn't look at it real seriously, hard in depth, but it just, had less turns than some of them I've seen. So it may be the right ratio anyway.
Yeah.
I guess that's kind of one of those things you get from buying from, Chinese Super Ultra Kung Pao Chicken Express,
Oh, Howard,
Yes.
the record is still on. I didn't know if you wanted to stop it or not.
Well, yeah, I will stop it. Might as well. I'll probably edit a bunch of this out anyway.
Yeah.
Just an example, Zach.